Hello everyone. Today's question is take gifts from the richest pile. So in this question, what we are given is there is an array of gifts. What we have to do is we have to choose a pile with a maximum number of gifts. So each pile has a maximum number of gifts. So you can see in this case, the maximum number of gifts is 100. So we have to choose that. If there is more than one pile with a maximum number of gifts, we can choose anything. Like if there was 100, one more 100, we can choose any one of them. So we'll leave behind on the floor or the square root of the number of gifts that are there in the pile. So what does that mean is, so let's say we had 100 gifts. So we picked the fifth pile and we leave behind 10 gifts on the floor again. So those 10 gifts again becomes part of this pile, right? So the first solution that comes to my mind is sorting this array. Uh, and again, I mean, so this can be a little bit tricky because every time we pick up, let's say if we picked up 100, right? And then we have to put 10 gifts back into the array. So then we put 10 back, and it might be possible that this 10 can be picked up again at later stage, right? So uh, and then again we have to sort it because these 10 can also be included at later stage. Let's say is 64 is processed and then 25 is processed, and after that 9 is there, but 10 is greater than 9, right? So in that case, okay, finally the last pile is chosen again and three gifts are, so the remaining gifts are this 5, 8 because of this, 3 and 9. Yeah. So we chose the gifts from the 10 pile because 9 is, or 9 and 4 are already there. So 10 can be chosen again. So we have to again sort it after picking up and putting the gifts back. We have to again sort it. So the complexity of this can become n squared log n, because every time we are sorting this, we are picking up the last one and then we are uh, inserting that. So a better approach can be using a priority queue, right? And with priority queue, we can also make sure that the size of the priority queue does not go beyond 4. So every time it has to insert into the array, it has to just use log k time instead of n time. So yeah, in the previous, I said n square log n, it should be n into k into log n, right? So we have to do the sorting only k times, not n times, right? So the complexity then with the priority queue becomes n log k. So that's what we will be using, right? So while inserting the array, will also count how many gifts are present. For that, we'll and we don't want a normal priority queue. We want a reverse priority queue because we want the maximum element to be at the top, right? So what we'll do is we'll go through the gifts. Sorry, gift, uh, gifts. Then we'll add to priority queue and also increase total gifts plus equals to gift. And if pq dot size is greater than k, then we pull out one. Okay. So in this case, polling would not be optimal because if we pull out, the maximum will be pulled out of it, right? Not the minimum. Uh, okay, so just leave this for now. We'll see if we can improve the complexity later. Okay, so we have got this. Then we do while a is greater than 0, we do gifts, total gifts minus equals to math. Okay, we have to store it somewhere so that we have to insert it back again. If remain. So we picked up the maximum math dot square root of pq dot whole, make it as int, right? What does it say? Okay, it accepts a double. Make it as double this, and then we int per gift. Just taking this. Here. Okay, we will just keep going. I think there are sometimes it just gives unnecessary exception. Right. So now we have to in from total gifts we'll deduct. So we have taken out per gift and my gift. So we'll add these things, right? I mean, if I just remove this just to make it intuitive. Right. So we are how much gifts are we have to subtract? We have to subtract. So how many gifts we have taken? We have taken current gift. So the one that we have pulled out, let's say 100 minus gift remaining. So the gift remaining will get into the total gift, right? So 100 minus 100 minus 10, and that becomes 90. And we deduct from the total gift. And then we have to insert the gift remain back to the priority queue, decrement the k value, and then current gift is double. So it runs A. We are at 99%. I think this is the optimal solution. Thank you.